Okay, this is a video on solving quadratic equations graphically, so that means with a graph, which you're going to do with your calculator. Just before we get into it, so just a bit of vocabulary. Should be all review, but sometimes people forget the vocabulary pretty quickly. Solving an equation, that means that you find the value or the values of the variable or variables that make that equation true. It could be several variables. So for example, if we had an equation that was 3x plus 1 equals 10, the solution to that is x equals 3. Because if you do 3 times 3, you get 9 plus 1, and it equals 10. That makes it true. Okay? If we have an equation, so this is a linear equation, this one's quadratic. X squared plus 2x plus 2 equals 5. I'm claiming that there's two solutions to that, and they're x equals 1 and x equals negative 3. So to check, sort of to prove that that's true to you, I'll do them one at a time. I'll check my x equals 1, and I'll replace my x's with 1's. Okay? So I have 1 squared plus 2 times 1 plus 2. So that's equal to 1 plus 2 times 1 is 2 plus 2 is 5. And that's what I said it was equal to. So that one works. And then if I check x equals negative 3, I'll substitute x equals negative 3. So we have negative 3 squared plus 2 times negative 3 plus 2. And that's equal to negative 3 squared is 9. Remember, it's positive because negative times negative is positive. 2 times negative 3 is negative 6 plus 2. So 9 minus 6 is 3 plus 2, and that is 5. So because both of these come out to what it said it was supposed to come out to, that means these are solutions. I didn't show you how I got them. I'm just showing you what it means to have a solution. Okay, and then just another little bit of vocabulary. The roots of a quadratic equation, that's the same thing as the solutions. So if I ask you to find the roots of an equation, it just means to solve the equation. Okay, now I have a confession to make. It's Sunday night and I forgot my calculator, and I'd like you to watch this video on Monday. So, I'm going to do a couple questions here, but I want to show you how to solve them graphically, which means essentially for you with your calculator. So, I'm going to use my pretend calculator. I will upload a new video of me using an actual calculator, but it'll probably be about 5 o'clock on Monday. So you can wait if you want, but if you can't wait, I'll go through all the steps and everything, and then I'll show you some of the relevant things on the pretend calculator. Okay. So here's a question. A bird's height during a dive is given by h equals 8 times t minus 1.5 quantity squared plus 7. And I put this asterisk here to explain what the variables are. H is the bird's height in meters off the ground, and t is the number of seconds since the bird started the dive. I just didn't write that down here because I only have this much space. So the question is, when will the bird be 10 meters high? Now you might recognize this equation and the bird because you had some questions about this bird on your test. Okay, so what we want to know is when the height is going to be 10 meters. Right? You had a question about like how high will the bird be after 2 meters, and you could just substitute after 2 seconds. Sorry, you could just substitute t equals 2 and then simplify. But here we want to have 10 for the height. It's going to equal 8 times t minus 1.5 squared plus 7. Okay. And this turns out to be, so essentially here we know y, and we'd like to know x, we know h, and we'd like to know t. And this is actually a significantly more difficult problem than the opposite, if we know x and we want to know y. So we're going to spend about a week doing it, but this is sort of the easiest way to do it. So what we're going to do is, it's pretty easy to solve with your calculator. What you do is you graph two equations. You graph essentially you graph y1 equals whatever's on the left-hand side of the equals. Sometimes it might be something long and fancy. In this case, it's just 10. And you graph y2 equals whatever's on the right-hand side of the equals, but also just switch it to x's to put in my calculator, my pretend calculator. Okay. And then I'd like to see a graph. So you can press graph. If you have any questions about the window settings on this one, we want to know when the bird's 10 meters high. You can play around with this a little bit. But if you put x between about, so if x min and x max from maybe negative 5 to 5, that works. And then your y, so these again are the window settings. And then your y, the bird never hits the ground, because it would give it a concussion. We could crash the bird, we don't want to crash the bird into the ground. So we can put 0 for our lowest y, that'll do. And you may or may not remember the bird started 25 meters in the air. You probably don't remember that, but if you play around with it, you'll see. You can see everything good if you go up to 25. And so if you do this, you get a graph that looks about like this. Okay. I suppose we could have equally well started at 0 there. In fact, in some ways, let's check that. Because the bird's not diving when t is negative. The time starts when the bird starts to dive. So we have this graph here. What we want to know, this line is 10 meters high. This is y equals 10. So we want to know what there's going to be 2 times when the bird is 10 meters high. Okay? So we want to know the coordinates of those 2 points. So here's what you do. You press calc, and that's the second button, and then the trace button. So you should do this along with me as I do it. And just pause it if you need a second. And then choose intersect. And so you should be looking at the graph. If you're not, you press enter. And then down on the very bottom of the screen, it says first curve. And if you look at your screen, there's a little x somewhere on this y1 line. If you put your equations in the opposite order, it'll be on the parabola, but otherwise there'll be a little x maybe here or here. Okay? And so what it wants to know is that, it's asking, do you mean the intersection of this curve and something else? And you only have 2 in there, so you definitely do mean that. So you can just press enter to show it that you mean that. And then it's going to ask second curve, and then you just press enter. Because, yeah, you want that one. And then it asks you for a guess. So here's the story. There are 2 solutions. The way it's going to decide which one to give you is which one you put your guess closer to. So you should move your cursor over until it's right on top of one of them. So for example, if I do the one on the right first, my cursor will be right here on top of that, or as close as I can get it. So I'll put move cursor, and then press enter. You can also just put in an x value for what you think. So if this looks about like 2 to you, you could put about 2. And then down on the bottom, it'll give you x equals and y equals. So the way you should write those down is just by as coordinates points here. And you can round to 2 decimal places, so to the nearest hundredth. So what it is here is it's 2.11. The number after that is a 2, so that'll round down to 2.11. And then the y value is 10. This makes sense that the y value is 10 because we know that line is 10 high. To find the other intersection point, you go back to calc intersect, first curve enter, second curve enter. And then the difference is when it asks you for your guess, move your cursor so it's right on top of the other point. Okay? And then press enter. So the coordinates of that point are 0. So it says 8, 8, 7, and then some other numbers. I want to round to the nearest hundredth. So it was either 0.88 or 0.89, because it's a 7 that comes next. It rounds up. 0.89, 10. Okay. So here we go. We've talked earlier about graphical solutions. We talked last week about graphical solutions and what we need. There were 4 things on the list. The first one is a graph. We've got that. The second one is the equations that you graphed. In this case, when we're solving an equation, there are going to be 2 of them. So we have that. The third thing is the relevant points, and so they have to be labeled. You have to put a dot there and the coordinates. So we have that. And then the fourth thing is the answer. So we actually don't have that yet. So we'll just write a sentence. The bird will be 10 meters high. So it's twice, 0.89 seconds and after 2.11 seconds. Okay, so there's the fourth thing we need for a graphical solution. Okay, if that was super easy to you, I'll put up the next question and you can pause it and do the solution and then fast forward and check. Now, if it wasn't super easy, you should do it with me. Okay? So, here's the question. Here's my fresh pretend calculator. I'm really sorry about this. I'll fix it. It'll be around 5 o'clock on Monday, then I'll get the new one up. Okay, the question says, the hypotenuse of a right triangle measures 10 centimeters. Remember, the hypotenuse is the longest side. One of the other sides is 2 centimeters longer than the third side. Find the unknown side lengths. Okay? Okay, so I drew a right angle triangle here. The hypotenuse measures 10 centimeters, so that's here. One of the other sides is 2 centimeters longer than the third. So what I'm going to do is I'm going to call the shorter one x. And then the other one is 2 centimeters more, so that's x plus 2. Okay. If you called the longer of the two x, the other would be x minus 2. You'll get the same answers if you do that. Okay, and then we need to come up with an equation somehow to solve this. And you essentially know one real good equation about right angled triangles, which is the Pythagorean theorem. A squared plus b squared is c squared. Remember that the c squared is the hypotenuse, and these are the two sides, or the other two sides are the legs. So in this case, maybe our a is x, and then the b would be x plus 2, and the c is 10. Okay. So one side squared plus the other side squared equals the hypotenuse squared. Okay, and we actually have, right now, we've got a quadratic equation right there. If you felt like it for some reason, you could simplify this, multiply this out carefully by writing this twice, and then using distributivity. But you don't really need to. You don't even really need to write this 10 squared is 100, but you don't even really need to write that either. Okay? So here's what we'll do. We're going to graph, we want to solve this equation. And so we're going to solve it just like we did before by graphing y1 is the left side and y2 is the right side. Okay. So I'll put y1 is x squared plus x plus 2 quantity squared, and y2 is 10 squared. You can put 100, it doesn't really matter. Okay, so we'll graph those. And the graph of that, I'll suggest you can play around with the window settings. Pause it maybe right now until you get the window settings. And then in a second I'll give you some, just in case you have trouble. Okay, so the window settings I used x between -10 and 10. And then my y value, I know that this is going to be a straight, it's going to be a straight line, and it's going to be at y is 100. So because I'm kind of interested in seeing what's going on, I'll start my y's at 0, and I'll go up to 110. Any settings will actually work. You could go from 99 to 101, as long as they include the line at y equals 100. But it's kind of more interesting to go from 0 to 110, because then we can see the parabola. Okay, when we do that, get a graph that looks something like this. And it meets at these 2 points. So copy it the best you can. And then again, we're going to press Calc Intersect. So remember the calc is second trace. And it's intersect because we want to find where these two lines intersect each other. So we just intersect. And then it says first curve, and you press enter. Second curve, enter. And then you've got to make a guess. And by making a guess, I mean put the cursor right on the top of the intersection point, or alternatively put the x value in that you think that intersection point is at. So this intersection point, it will give us the coordinates. It's 600. And then pause it for a sec while you find the other one. Okay, the other one is at -8, 100. Okay. So back to what this means about my equations. Actually, if we look at the graphical solution first, I have the graph, I have the equations I entered, I have the relevant points with dots and the coordinates. I don't have the answer yet. Okay, if we go back to the picture here, x is the shortest side length. So here I found my x values are the relevant things here. And so I have x is -8 and x is 6. But if we think about this, x is -8, that doesn't make any sense to have a side that's -8 centimeters long. So what we're going to do, if we have answers that don't make sense in the context, you can put a big X through them, and then write the word discard. So that means it's a solution to this equation, but it doesn't make sense in the original context of the problem, because we can't have a side length of -8. So that means that one of the sides is 6. Let's write this under here. The side lengths are 6 centimeters. That's for this one here. And then the other one is x plus 2 and 8 centimeters. And the hypotenuse is 10. X plus and 10 centimeters. Okay, so we have, and check that we've got all these things when you do graphical solutions. We have the equations that we entered, both of them. We have the graph, we have the relevant points with dots and the coordinates, and then we have the answers. So there's the last thing. Alright, see you tomorrow.